called rational functions. These are some things when you've got fractions, like something like 2x minus 4 over x. And so if we said, okay, that's greater than or equal to 7, you may instantly think, okay, let's do this. And then, all right, 5x is going to be less than minus 4, so x is less than minus 4 over 5. And you'd think that's the right answer. Let's just try minus 1, though. That's equal to minus 2 minus 4, which is minus 8, I think. No, that's minus 2, minus 4 is 6, not multiplying, sorry. Over minus 1, which equals 2, 6. And somehow I don't think that's particularly greater or equal to 7. So what went wrong? That just comes back to the rules of what you can and can't do with inequalities. Add the same number? Can. Subtract the same number? Can. Multiply by same positive number? Can. Divide by same positive number? Can. Multiply or divide by same negative number? Cannot. If you do that, you must reverse the sign. So if I were to say, in a simpler example, minus 2x is less than or equal to 4, I would have to go like that. When I divide it by the negative, I would have had to reverse the sign. So when we multiply by x, we don't know if it's positive or negative. So we have to be careful about that. So what we would do is we would put everything to one side to get it to equal to 0. And then we just need to find our critical points again. We need to find when this will equal 0. So we need to find some critical points and then see what works. So we'll combine this into one fraction. And this is okay because we're keeping it. This is minus 7x over x is the same as minus 7. So that's still okay. And then we get minus 5x minus 4 over x, and that's greater or equal to 0. So we need to find what happens when we have the numerator equals 0 and what happens when the denominator equals 0. So this becomes x equals minus 4 over 5. So let's just, and we split at these intervals. We need to see, okay, when x is less than negative 4 over 5, x equals negative 4 over 5, it's between 0 and when x is greater than 0. And all we need to think about is whether it's positive or negative because it's in relation to 0. So let's say when x is less than negative 4 over 5, for example, negative 1, that's equal to 1, and then 1 over negative 1 equals negative 1. So that's less than 0, so does not satisfy. And then x equals negative 4 over 5. That's equal to, well, those 5's will cancel out, so you get 4 minus 4 over minus 4 over 5, and that's 0 over something which will equal 0. And that does satisfy, because it can be equal to 0. And what about in here? We know that whatever one we pick in the range, because it's in between the critical points, they'll all give the same result in relation to 0. So let's try minus 1/2. Oh, well, just to make it easy, we'll do minus 1/5. Well, that gives us 1 minus 4 over minus 1/5. So that's 3 over minus 1/5. Minus 3 over minus 1/5, which will give us 15. And that does satisfy because that's positive. And then at x equals 0, that is undefined because you can't divide by 0. And then if x is greater than 0, say 5, then that will give us minus 25 minus 4 over 5, and that will end up being negative, so does not satisfy. So therefore we can say that for this to be true, we'll say x must be in the range, it can equal negative 4 over 5, but it has to be less than 0.